This question asks us to calculate the density of a specific gas at STP. A couple different ways we can do that. First of all, let's look at using an equation that we derived in one of the lesson videos. And if you forget how to do that, you can see the lesson video. And the equation itself is that the density of a gas is going to equal pressure multiplied by the formula weight divided by R and the temperature. So we would just substitute in the values from our problem and calculate out our answer. At STP, we know that the pressure is exactly 1 atmosphere. The temperature is 273.15 Kelvin. We're going to divide by R, 0.08206. Our units are liter atmospheres per mole K. And finally, we multiply by the formula weight of methane, which is 16.05 units of grams per mole. Let's take a look at our units to see how we're doing with our setup. We see K cancels. Our atmospheres cancel, moles cancel, and the units that survive are grams over liters, which is the correct unit for the density of a gas. Let's do our calculation. All the numbers on the top indicate multiplication. Those numbers in the denominators indicate division. So if we chunk all this out, we get 0.716048. Again, the units are grams per liter. Let's look at our sig figs. Now note this number here, the atmospheres. This actually is an exact number. I've written it with 3 sig figs, but because this is at STP, we know the pressure is going to be exactly 1 atmosphere. Here we have 5 sig figs, 4, and 4 here, so we're limited to 4 sig figs, and our final answer is 0.7160. Units are grams per liter. Okay, so that's one way that we can solve this problem. Another way we can solve this problem is making use of the fact that we have a gas that's at STP. We know that the standard molar volume of any gas at STP is the same. So on this specific question, we can take a shortcut. We know that the density is going to equal the mass of 1 mole of gas, which is its formula weight, 16.05 grams, and its molar volume is 22.41 liters. And when we do the math, it comes out the same as our first calculation, at least within sig figs. 0.716198 units are grams per liter. With 4 sig figs, 0.7161 grams per liter. The slight difference in the last sig fig has more to deal with the number of sig figs we're using in this equation as opposed to anything else.